What is capacitor and their types?
In this video, we are going to check the work of the capacitor. The capacitor consists of two metal plates that are separated by a non-conductive or dielectric material. In this video, we will examine the performance of the capacitor in two states of constant voltage and constant electric charge.
Although any non-conductive material can be used as a dielectric, in practice, certain materials such as porcelain, mylar, Teflon, mica, cellulose, etc. are used for this purpose. The capacitor is defined according to the type of dielectric chosen, and also the type of dielectric is effective in the application of the capacitor.
For different applications, different materials are used as dielectrics. For example, in radio tuning circuits, air, in mylar timer circuits, for high voltage applications. And for use in X-ray and MRI machines, ceramics are mostly used as dielectrics. The metal plates of the capacitor are separated by a distance, and the dielectric material is placed between these plates. Dielectric is the main material in the capacitor that helps to store electrical energy.
A capacitor is like a battery. Although the two work in completely different ways, capacitors and batteries both store electrical energy. If you are familiar with how batteries work, you know that a battery has two terminals. Inside the battery, chemical reactions produce electrons at one terminal and absorb electrons at the other terminal. A capacitor is much simpler than a battery because it cannot absorb new electrons and only stores them.
When a capacitor is in electrical equilibrium, none of its plates have an electrical charge. When we charge it, the electric charge Q moves between the plates. This displacement causes one plate to be charged with Q+ and the other with Q. Considering that we are dealing with two charged plates, therefore, a potential difference can be defined for it. Note that in the following we will denote this potential difference by delta V. It is also clear that the net charge on the capacitor is always zero, and it is only the charge distribution that leads to the potential difference.
Experiments show that the amount of charge Q stored in the capacitor has a linear relationship with the potential difference V of the two planes. Therefore, the amount of charge stored in the capacitor can be expressed as a formula.
Usually, the capacity of capacitors varies from picofarad to millifarad. 1 picofarad is the lowest capacity. In electrical circuits, two parallel lines are used to indicate the location of the capacitor. Of course, there are different ways to represent the capacitor in the circuit. You see two conventional ways to represent a capacitor.
Capacitors are made in different types and sizes, and one type of capacitor is not suitable for all applications. These parts are generally divided into two types, fixed and variable, with different dielectrics. Each of these types of capacitors is suitable for its own application. In the following, we describe the suggested uses of each capacitor. But in general, the applications of each capacitor are written by the manufacturer on its catalog. Types of electric capacitors.
Fixed capacitors are usually defined and identified by their dielectric. Dielectrics commonly used in fixed capacitors include ceramic, plastic, and mica. In electrolytic capacitors, aluminum and tantalum oxide are used as dielectrics. Tubular and entangled plates are types of designs of this type of capacitors.
In this design, several metal plates are used to increase the effective cross-section of the capacitor. Metal plates are separated from each other by insulating layers. These pages are connected to each other. Finally, this capacitor is covered with epoxy resin or other insulating material. Electrolytic capacitors.
Electrolytic capacitors have relatively high capacity. With a relatively low cost, capacitors with a capacity of several thousand microfarads can be made. In this type of capacitors, an oxide layer is used as a dielectric. Due to the thinness of this layer, the capacity of these types of capacitors is high. However, these types of capacitors have relatively high leakage and low breakdown voltage. The metal plate of electrolytic capacitors is generally aluminum or tantalum. Tantalum-type capacitors are smaller than aluminum-type and have less leakage and more stability than their aluminum-type.
On the body of this type of capacitors, the maximum voltage that can be tolerated by the dielectric is entered, and they have two positive and negative bases. The negative pole of the electrolytic capacitor is marked with a white or black strip. This type of capacitor is used to smooth, remove low-frequency noises, and remove voltage waves in the power supply part of circuits. Ceramic capacitors.
The dielectric used in the structure of this type of capacitor is ceramic. The high dielectric constant of ceramics makes it possible to make capacitors with very high capacity in small sizes. Therefore, ceramic capacitors are also called lens capacitors, because their size is as small as a lentil. However, they have a very high working voltage. But unlike electrolytic capacitors, they do not have positive and negative poles, and their capacity depends on the ambient temperature. This dependence on ambient temperature can be introduced as the biggest disadvantage of this type of capacitor.
One of the important applications of ceramic capacitors is to eliminate noise in the power supply of circuits. On the other hand, due to the excessive sensitivity of digital circuits to power supply voltage fluctuations, this type of capacitor is placed at the closest point to the ASC in order to improve the power supply. Polyester capacitors.
Polyester capacitors are widely used in circuits due to their good characteristics. In this type of parts, thin plastic sheets are used as dielectrics, which are placed in a plastic frame together with thin aluminum sheets. Polyester capacitors are not very sensitive to temperature changes. For this reason, they are used in cases where a capacitor with a constant capacity compared to heat is needed. The name of this type of capacitor is also due to one of the dielectric materials used in it. This material is called polystyrene. These types of parts do not have positive and negative poles like the ceramic type.
Tantalum capacitors.
Tantalum capacitor is a type of electrolytic capacitor in which tantalum metal is used in the device. Tantalum has a much higher dielectric constant than the comparison. This caused the capacitor type to have a much higher capacity than this type of machine in the same volume. Also, its price is higher than other capacitors. This type of capacitor is produced and supplied in two models. In the DIP type, the positive pole of the capacitor is written next to its base, and in the SMD model, it is indicated by a line. The high area of tantalum capacitors allows its production in smaller sizes.
It also has a very low leakage current and a longer lifespan than other types of capacitors. However, their ability to withstand low charge and discharge currents and their capacity are limited, usually up to 330 farads. To support me, subscribe to my channel. Like my videos. Press the bell button for notifications. Subscribe to my channel for new videos. Share my videos. Write me a comment. Thank you.